In this video, we are going to say more on progressive wave and solve some questions on progressive wave. Most students have been asking best, how can we solve progressive wave? Okay, in our video today, we are going to solve more on progressive wave questions. But in case you missed our previous video on waves and waves parameters, you can just watch those ones so that I can get used to anything about wave. Okay, now in terms of progressive wave, when we are saying about progressive wave here, we mean continuous wave. That means progressive wave is the same as continuous wave and also stationary wave. Okay, now but what you have to know here is that in progressive wave can either move in sine form, that is, can either move in sine waveform, please take note, or cosine waveform, please take note. Now we are going to know when a progressive wave is in sine waveform or cosine waveform. Now listen, whenever a progressive wave is actually in reference to the origin, or when t is equal to 0, please take note. Whenever the waveform is in reference to the origin or t is equal to 0, at that point it means that the progressive wave is going to be class in sine waveform. But when it is not in reference to the origin, or there is nothing like t equal to 0 here, at that point is going to be under what class? Cosine waveform. What does it mean here? It means that, remember in our classes, we know about sine graph and cosine graph. In terms of sine here, we have the graph to look like this, that is starting from the origin here. Please take notes. Okay. Please take note of this. This is called sine graph. That is, sine graph always starts from the origin. Please take note. But if I have something like this, a graph like this, okay? If I have a graph like this, okay? Now, this graph does not start from the origin here. We call this cosine graph, okay? Now, in summary here, what does it mean? It means that progressive wave equation can either be represented in sine form or what? Cosine form. Please write progressive wave equation. Please write progressive wave equation. Okay. Okay. Please write progressive wave equation. That is progressive wave equation. Now we want to look into the progressive wave equation here. Okay. Now in terms of progressive wave equation here, it can be written as y is equal to a sine into omega t plus or minus phi. We are going to know what omega is. We are going to know what y is. Where our phi, which we are going to know what it is said to be 2 pi s over what? Lambda. The same thing here. We can also write the equation in terms of cosine. That this will be y is equal to a cos into omega t plus or minus phi, where phi is said to be 2 pi s over what? Lambda. Okay. Now let's know the parameters here. This y here is said to be displacement. Please take note. This a here is said to be amplitude. This omega here, listen to me. Whenever you are comparing omega, this omega here at this point is said to be angular frequency. But this is what you should know about omega here. Omega takes the place of what you are comparing it with, or what you are relating it with. If you are relating omega with velocity, that is, if I have v is equal to omega r. If you are relating this omega with velocity, you will call this omega here angular velocity. But if you are relating this omega here with frequency like this, omega equal to 2 pi f, if you are relating this omega here with frequency, we are going to call this omega angular frequency. So omega is always written depending on what you are referring it to or relating it with. Please take note of that. All right. We say where phi, that is, this phi here represents phase angle. I will tell us the difference between phase angle and phase difference. Also the same thing here, that is 2 pi s over what? Lambda. Okay. Now I was trying to explain to you guys, listen please, when the omega is said to be angular velocity and angular frequency. If you are relating omega with velocity, it's going to be angular velocity. That is this omega here. But when you are relating it with frequency, it's going to be angular what? Frequency. Okay. But let's try to know more again about this particular progressive wave equation here. We say that this y is displacement. We say that this a is what? Amplitude, of course. So that this omega is angular frequency. This t here is time. Now plus or minus depends is the sign depending on the one given to you in the equation. Please take note. But when this is said to be plus, what does it mean in terms of wave? It means that the wave is moving from the right to the left. Please take note. If it's plus here like this, it means that the wave is moving from right to the left. Please take note, to the left. Okay. We are using R here to represent right, whereby the L here is what? Left. Now, if it is minus, it means that it's moving from left to what? Right. Please take note. Okay. That is what this plus or minus indicates. Why this phi here is said to be what? Phase angle. Please take note of this. So let's try to know how to solve any equation when it comes into what? A progressive wave equation. Okay. Now let's take the concept of how to solve progressive wave equation. All right. Okay, let's take some steps on solving progressive wave equation. Okay, steps. Okay, number one, compare the standard equation with the given equation. Now, what does it mean here? Now, the standard equation for progressive wave is said to be this or this. If in the equation there is given to you as sine, you use this standard one here, the sign, the one that is said to be under sine. Now, if the equation is said to be in cos here, you use this one here that is said to be what? Under cos. Okay. So you have to compare the standard one with the given one. Okay. Number two, calculate the wave parameters from the progressive wave equation. Okay, now you have to compare, listen please, you have to compare the given one, the one that will be given to you in the equation, and maybe this standard one, and find all the available parameters before you calculate what you are asked to calculate. Please take note. Okay, let's solve question one here to understand the steps. Okay, example one please. Progressive wave. A plane progressive wave is represented by the equation y equal to 0.2 sine 100 pi t, pi is a constant value, minus pi s over 17. All right. Determine A, the frequency of the wave, B, its wavelength, C, its speed, D, its phase angle at 34 cm from the origin. All right. Now, some questions, they might attach a unit here, cm, which we are going to solve later. But at this point here, they not attach any unit to it. That means everything here is said to be in what? SI units. We are going to solve a question whereby they attach maybe a unit here, and we know what it means to us. Okay. But let's solve this guy here. In solving any equation in terms of progressive wave, this is our concept here. Number one, compare the standard equation with the given equation. So what is the standard equation in terms of progressive wave when it comes to sine? It's said to be y is equal to a sine into omega t. Please take note. Since here is minus, I'll use minus phi. Okay. Now this is the standard equation for progressive wave when it is said to be obscure sine. So the next one here is, okay, with the given one. Which of them is the given one here? This is the given one here. So this will be y is equal to 0.2, okay, sine into 100 pi t minus pi s over what? 17. Okay. Now we have compared this standard one here for progressive wave to the given one here, which is this guy here. So let's go. So now the next one is calculate the wave parameters from the progressive wave equation. So now let's find all the wave parameters here before we solve what we are asked to solve. Okay. Now this is amplitude under comparison. This is displacement. This displacement. Okay. Now anything that stands here should be what? Amplitude. So what is standing here, please class? 0.2. So that means our amplitude is what, class? 0.2. Remember, since there is no unit given to us here, it means that everything here should be under SI unit. And the SI unit here for amplitude is said to be meter. Please take note. Now let's compare. There's nothing like sine when it comes to wave parameters. So I'm not going to compare this guy and also this guy here. So let's compare here. Compare here and here. We are going to have omega t is relating to 100 pi t. Okay. Now if you look into this here, there is something common here, also common here. What is that? T. Divide both sides by t. I'm going to have omega is equal to 100 pi. Now the unit of omega is said to be rad per second. Please take note. Now let's go again. This is minor to be cancelled. Now this represents this guy. That means our phi is said to be pi s over what? 17. Okay. Now this is what we should do first before we calculate the parameters we are asked to calculate. Now let's do this. The first question here is the frequency of the wave. How do we calculate the frequency of the wave here? Which of the parameters that can be related to frequency? This is amplitude. This is angular frequency. This is what? Phase angle. Please take note. Okay. Now the only formula that can be related to frequency is said to be angular frequency. What is the formula here? In case you have not actually watched our video in terms of wave parameters to get some of the formulas, you can go back to watch those videos. Okay. Now what is the formula here? Let's solve this. Now the only parameter here that relate to frequency is said to be angular frequency. And what is the formula? We say that omega, we are solving A here. Omega is equal to 2 pi f. Okay. Now this guy here is given to us, of course. Now we are asked to find frequency here. So looking for this guy here, that means I'll make f the subject. But let's impute the value here. Omega is said to be 100 pi. Please take note. Is equal to 2 pi f. Now making f the subject, I'll divide both sides by what is attached to f. If I have something like this, that is 2s is equal to 6. So find s here, I'll divide here by 2. Also divide here by 2. Please take note. So do the same thing here. I'm going to have my f here, divide here by 2 pi, divide here by 2 pi. Please take note. So what does it mean here? It means that our f here will be equal to class, this cancel this, is equal to 100 pi over what? 2 pi. So this can cancel this. Please take note. This can also go here. This will be equal to 50 what? This class. Hence. Okay. Now we have solved this here. Now the next one here is said to be its wavelength. Now how do we get wavelength here? We go back again. Which of the parameters here that can be related to wavelength? Of course, an amplitude does not have any formula related to wavelength. Angular frequency does not have any formula related to wavelength except frequency. Again, the only one that have the formula that is related to wavelength is that phase angle. You can say that phase angle phi is said to be 2 pi s over what? Lambda. Please remember this. Okay, let's solve for this, please. All right. Let's solve the wavelength here. And I told you guys that in terms of the wavelength here, the only parameter here that relates to the wavelength is what's class? Phase angle. Why? Because we say that phase angle phi, okay, this is B. Phase angle phi is said to be 2 pi s over what? This class? Lambda. Okay. Now, what does it mean here? It means that I have to compare this guy. This phase angle is already given to us here. That's what? Pi s over what? 17. Anywhere I see phase angle, I replace this to be what's class? Pi s over what? 17. And this is s also. And this is our what? Lambda. Remember, the lambda here represents what? Wavelength. So let's replace. Anyway, I see this phi here is given to us from the expression there. It's said to be pi x over 17. We are replacing this guy here. Is equal to 2 pi x over what? Lambda. So our intention here, class, is to make this lambda the subject of formula. Making this lambda here the subject here, I'm going to have this to be. Now, making this lambda here the subject here, I'm going to have this to be. But let's cross multiply here. We are going to have pi s times lambda is equal to 2 pi s times 17. So let's find lambda. I'll divide both sides by what is attached to lambda here. This will be over what? Pi s over what? Pi s. This will cancel this. Our lambda will be equal to class. This will also cancel this. This will give us 30 what? 34 meters. Okay. So this is the value for what? This class lambda. Okay. Now let's solve the next one here. Speed. Now how do we get this speed here? Remember that lambda is given to us, and of course frequency is also given to us here. Now what is the formula for velocity that relates with frequency and lambda? We said that velocity v is said to be f what? Lambda. Okay. Now let's replace. What is our frequency, please? Our frequency is what? 50 times. Remember, we calculated the frequency to be 50 here. Times. What is our lambda, please, class? 34. Okay. Now that means velocity here will be equal to 50 times 34. Let's go here. Okay, look up here. 50 times 34 is said to be 1700 meter per second. Okay, these are velocity here. Now the last one here is said to be its phase angle at 34 cm from origin. Now I told you guys that whenever there is a reference to the origin, it means that that particular waveform should be what? Signed. Please take note. Or whenever t is equal to 0. So how to know the waveform in terms of progressive wave, the waveform that is said to be sine, or the waveform that is said to be what? Cosine, is that the waveform that refers to the origin is said to be class sine, while the waveform that does not refer to the origin is what is class cosine. Please take note. So from here we can easily know that this waveform here is what is class sine. Please take note. But let's try to solve this. They say its phase angle at 34 cm from the origin. So that means we are asked to find the phase angle when the distance is given to us as what is class 34 cm. So let's solve this, please. Okay, let's solve this. From the formula here, we say that phase angle is said to be 2 pi x over what? Lambda. But remember that phase angle, okay, let me try to hit on this. Phase angle and phase difference is not the same. Now, when we are saying about phase difference here, phase difference is said to be the difference in the distance here. That is this 2 pi s2 minus what? S1 over what? This class lambda. Please take note. So this one here is what we call phase difference. This one here is what we call what is class phase angle. Either I call it phase difference or phase shift. Please take note. When there is a shift in the distance, we call it phase shift or phase difference. Okay. Now, since we are asked to calculate the phase angle here, we can use this formula here. Now let's replace. Our phi will be equal to 2 times 3.142 from the constant value here. Pi is said to be 3.142 times. Now our s is already given to us there. That is the distance of the phase angle, said to be 34. But in physics, we don't use cm, we use what's class meter. So divide here by 100. I'm going to have this to be 0.34. Or divide by, what's our lambda, please, class? Our lambda is said to be 34. Okay. Now punch your calculator. Our phase angle here will be equal to, what is the answer? 0.0628. Please take note in what? Rad. Okay. Now we use rad to measure this phase angle. Okay.